Okay, more practice rewriting a trig statement into an inverse trig statement. And for any problem like this, you could change it up, and here you're given sine, you could be given cosine or tangent, and likewise you're asked for something to do with sine of 2 theta. It could be cosine 2 theta or tan 2 theta. So understand that these could have different components just by changing the functions. The question here is, suppose that sine of theta is 5x and theta is in quadrant 1. It tells us quadrant 1 as 0 to pi over 2. Okay, so we know that theta is a quadrant 1 angle in standard position whose relative sine value is the value 5x. Now, one convenient way you could write that is 5x divided by 1, because that would give you the correct sine ratio, and anything that's correct is appropriate. The Pythagorean theorem would give you the missing side as the square root of the hypotenuse squared minus the opposite side squared. We could clean this up a little bit as the square root of 1 minus 25x squared. Okay. And so the deal here is for this particular figure, you can tell me not only the sine value that you already knew, you could now tell me the cosine value or the tangent value and so forth. Since r is 1, the cosine value is just the length of the adjacent side. Okay, now let's look at what we are supposed to do. We're supposed to find an expression that says theta plus sine 2 theta. Okay, well, theta is the angle whose sine value is 5x. We know that inverse sine definitely makes sense for quadrant 1. Okay, so we can take this statement, sine of theta is 5x, and we can rewrite it as theta equals arc sine of 5x. Those are equivalent. Alright, sine of 2 theta is an identity. 2 times sine of theta times cosine of theta. Alright, let's fill in the blanks here. So we have the angle theta, which is the inverse sine of 5x. And then we have plus 2 times the sine of theta, which is 5x, times the cosine of theta, which is the square root of 1 minus 25x squared. And this would be our expression for untangling theta plus sine 2 theta. And then we need to look at our choices to see which one is the best fit. Okay. Well, we have arc sine of 5x plus 2 times 5x, which is 10x, times the square root of 1 minus 25x squared. The square root does not distribute over addition or subtraction, so that's as far as we can go there. So let's look and see which of these choices models this expression. Okay, and looks like to me that our best fit here is the first one, has everything that we need.